Hello everyone, my name is Mike MacArthur. I'm from RobbJack Corporation, and we're going to do a seminar on high-speed machining of composite alloys. So if you guys have any questions during the presentation, something's not clear, feel free to ask, raise your hand, ask a question. This is for you guys, so the more you can learn, the better. And just a little bit of background. My name is Mike MacArthur. I've worked for RobbJack for about 16 years in R&D development, and we've developed many of the tools for composite machining. Probably in the last 10 years, there's been a huge increase of the type of tools that we're using. So one of the things to remember when you're cutting carbon fiber or some of the composites is that every material is different. A lot of times we get people that say you need to cut carbon fiber, and every one of those pieces that you see sitting there is a different material and with different cutting characteristics. So whether you have a random fiber, intermediate layers, vacuum bag process, pre-preg, they all vary the type of cutting that you'll do. So usually the biggest problem that you run into when you're machining different kinds of composites is the delamination of the layers, or the when you're drilling holes, breaking out of the fibers as you pierce through. So there's a lot of new machining geometry that we can do to combat that. So one of the main issues that's often overlooked is the fixturing of your part. When you're doing machining, the more rigid that fixturing is, the better outcome you'll have when you're machining. So having really rigid fixturing will increase tool life, give you more consistent operation. One of the most common is using vacuum fixtures. And the closer that you can machine that vacuum fixture, the better off you are. So you get better contact with your part to your fixturing. And we've seen even something as simplistic as using tape on areas of family of parts that you may only have one fixture that may vary from part to part, is using duct tape or masking tape to tape the edge to the fixture. Will actually help give you that extra rigidity while you're machining. We've also seen something as simple as using sandbags to throw on top of the part to help dampen it, to keep it from vibrating. So anything you can do to make it more rigid, the better you're going to have when you do the machining. So some of the cutting tools that you can use are common would be diamond coated drills, polycrystalline diamond drills, so that would be a solid sheet of diamond brazed onto the carbide. Polycrystalline routers, which would be a solid sheet of diamond brazed onto the carbide. Your traditional burr style type routers, and the diamond coated routers, which we have various different geometries that can give you up shears, down shears to combat some of the problems. So when you look at the three types of cutting tools, whether it be drills or routers, you have the diamond coating, the PCD, and the carbide. And when you look at the shock resistance, the diamond coated has the least shock resistance, PCD in the middle of the road, and carbide has the most shock resistance. So if you're having problems with chipping of your cutters because everything's vibrating really bad, you may want to stick more towards the carbide, because that'll give you the most shock resistance. The downside is when you go to the wear resistance, which is usually the biggest problem in machining composites. You wear out tools very quickly. The PCD and diamond give you the greatest wear resistance. So the better you can get that fixturing, the less the part vibrates, the more successful you'll be with tool life by utilizing diamond coating and PCD cutters. Traditionally, with when you drill holes, The problem you have is delamination and poor tool life. So what we can do is we can vary those angles on the drills to pierce through and then ream the hole as you go through to get rid of that delamination. So by having special point geometry like an elliptical point here or a double faceted angle, it'll really virtually eliminate all that delamination. I'll go ahead and pass a couple tools around. Start some this way. So some of the advantages of the diamond coating for drilling applications, really you want to stick towards the diamond coating and the PCD cutters. They give you the longest tool life. The downfall to a diamond coated tool is you get a one-time use out of it. Once it wears out, you can't resharpen it because it has a thin diamond coating. The advantage is it's a little less expensive than a PCD cutter. So it depends on what type of tool life you need, what type of material you have, but either diamond coated or PCD drills are really the way to go when you're trying to do a lot of holes in your composite materials. On the PCD side, it's very similar to the diamond coating. We want to vary those angles, pierce through that material, and then ream that hole as we go through to get rid of all that delamination or broken fibers on the exit of the holes. The advantage to the PCD is you have resharpen ability, so you can resharpen the drill after it's been used and you get multiple life out of it. The downside is the initial cost is a little higher than the diamond coated. Here's some drill. There's the drill that went through. So I'm passing around a part. Oh, go ahead. That's just from the fluting process. If you look at the tool underneath that you have, it's a little bit of the photography. It is a traditional tool grind, so there isn't a purpose for having those lines in the fluting. His question was, why isn't it not smooth? If you looked at the actual tool, and I actually have that exact tool at our booth, when you look at it, it is a smooth finish, so it's not for a purpose. The question was, do we offer the radius dual angle in the front, like an elliptical bullet point? Yes, we do. In the PCD side, we have it with double angles, single angles, and an elliptical point. So as it pierces through, it'll clean out that hole as you go through. So here we're going to show a video of the drill that we're passing around, and that's actually the part that was cut. And the thing to note is a lot of times speeds and feeds are usually done incorrectly, and that's what gives you a lot of poor tool life. When we cut this part, as you look, you'll see actual fibers and chips being formed. There's a lot of powder being formed, but you'll actually see chips being formed. That's because the feed rate is fast enough to actually form chips. So we're running this 1/4-inch tool at 35, 50 RPM, 3560, and 21.4 inches per minute. So when we pass around that part, you'll see the exit holes. You're seeing some residue here, just the powder sticking to the material, but that the part that's being passed through, there's been no secondary operations, no sanding, no deburring. That's the actual drilled hole that you're seeing. So the advantage of using PCD or diamond coating is you get 10 to 20 times the tool life over carbide. And then you don't get any of that delamination, none of the secondary work, sanding, hand sanding. You mill it, you drill it, and it's done. You don't have any of the problems that you would run into with using carbide drills. The next style of tool would be a router. And if you have very poor fixturing, your parts are vibrating, you can hear it cut, it's screaming, it's really loud, you probably don't want to go over to the PCD as your roughing tool. You may want to stick to the solid carbide router. And the reason is it has better shock resistance, so you don't run into the chipping problems that you may with diamond. So as an alternative, you may want to rough out your parts with the carbide. You won't be able to hold tolerances very well because you'll get extreme wear on the cutters. You'll have a little bit difference from the beginning of your part to the end of your part. But it's a really good tool if you have that vibration. So what you could do is you could rough with the carbide tool and then come back with the PCD very quickly, just skim up those edges. If you don't have a very rigid application, if you're just removing a small amount of material, it'll just clean it up. You'll get rid of that hand chipping and edges that are flaking off, and you'll have a really clean edge. The diamond coated routers typically aren't used as much as the PCD routers or the carbide, but if you have a part that you don't have chipping problems or things like that, you can use a diamond coated router. And you can see this variation here, we're able to put an up shear and a down shear on the tool so that it puts positive pressure on the top edge and positive pressure on the bottom edge at the same time. So it kind of squeezes the material into itself so you don't get delamination. And all the diamond tools do have RFIDs, so we can trace you through the building if you put it in your pocket. So. So when you get to the PCD router, which when you're trimming out parts, this is probably the most common tool used. It's usually straight flute so that you don't put there's no shear to it, so you're not putting up force on the part or down force. It helps get rid of those fibers from pushing up out of the way because it's kind of pinched between the material itself and shears off those fibers. It's really good for trimming. The other thing that you're able to do is cut through the part in one pass. You don't want, when you're working with very abrasive materials like composites, you don't want to rough the parts out, finish the parts, move in a little bit, step down. So in a typical application, you can go 1, 2, 3 diameters deep per pass in one single Z pass and machine it right to net shape. You don't want to rough it, finish it. You have a tool that's going to hold size. You don't want to double the amount of time that it takes you to machine the part, as well as double the amount of linear inches it takes to machine one part, so that you get half the tool life. So you want to go right to net size, machine right to your finished shape, with no hand finishing work required. So the video that we're going to show, the tool's running 10,000 RPM and 80 inches per minute. Typically, most people try to run their trimming tools too high of an RPM and too slow of a feed rate. And the problem is you generate too much heat. So by running it at a little more conservative RPM, but at a faster feed rate, we're able to get a lot more tool life out of the part. So that part that's being passed around, that slot was machined. This is actually the part on the video. So it's machined at 80 inches per minute. And once again, there were no secondary operations. That is the milled finish on that part. So no hand sanding, no deburring, no getting rid of those fibers. And that part is I believe it's a 737 floor spar for one of our customers. Another factor in cutting composites is your coolant system. A lot of times this is customer driven. They'll say you can't use a flood liquid coolant. We want this type of system, that type of system. So you may not, if you're like a manufacturer or a job shop, you may not have the ability to change the coolant. But if you do, anytime a flood coolant or shop air or mist on the process, if you're able to use it, will extend your tool life. If you're not able to use any kind of liquid type of coolant, even something as simple as a cold air gun or liquid nitrogen, there's some CO2 systems that I've seen. Any type of cooling system can benefit your application if you can use it. So on the troubleshooting side and proper tool life, I mentioned it before, you want to go not too high of an RPM, and you want to go a very fast feed rate so that your chip load is up so you don't build up heat. You want to get into the part and out of it as fast as you can. So that 3/8 tool that you saw had a 6,000 chip load and was running at about 10,000 RPM. So for composites, you're looking, depending on whether it's military or commercial aircraft or medical type things, typically surface footages range between 800 and 1,000 surface feet per minute. And you would interpolate a chip load of about 10 thousandths for a 1-inch tool. So a 1/2-inch tool, maybe in the 5 to 6 thousandths chip load, and you would interpolate down from there. As far as the troubleshooting, this kind of recaps what we're talking about. Feed rates between 40 and 80 inches per minute. You want to get rid of rubbing and heat buildup. So a 1/2-inch tool would be about 6112 RPM, and a 3/8 tool about 8150. And you want to go the full depth, and you can go up to 1.5. We have customers going all the way up to 3 times the tool diameter in Z depth to cut per pass. Some of the other issues with the diamond coating and PCD is you want to use non-contact measurement. When you measure your tools, you can't use a micrometer, you can't use calipers or other type of contact measurement with the tool. You want to use any kind of vision system. We can give you inspected reports with the tools that tell you what diameter, what length of cut everything is, just so you don't have to measure it. You don't want to use any kind of contact measurement with the PCD or diamond. You'll probably chip it when you make a measurement with a hard surface. Some of the problem-solving geometries, here's a typical up-shear style tool. This is the traditional style of tool that most tools are. It pulls up on the bottom of the material and pulls up on the top of the material. So if you have the top edge of your material fraying off, you may want to go with either down shear or a straight flute tool that'll put either down force on it or a neutral force. Or the other tool that we have is, the up shear, down shear combination, which puts up force on the bottom and down force on the top. So, when you're doing composite machining, you want to think of it as a process. Your tools, the tool holders, the machine, the rigidity of your fixturing all play a role into making a very successful operation. Some of our most successful customers, they really address it as a whole picture and a whole problem. And when they address each of the individual problems within the process, they're very successful in their machining and can machine composite materials with any kind of problems. Does anyone have any questions at all? The question was in a non-CNC type of operation, in a manual operation, you may be going through drill bushings or issues like that, or even hand routers. On the drill bits, we actually have a lot of customers using the threaded shank style tools that go into the machines, and they're doing it manually, where we do a drilled reamed hole and then actually a countersink built into it for aircraft. And that is a manual operation. You are able to do it manually. You just want to be careful when you're using the diamond tooling. The question was, are there special drill bushings? Unfortunately, on my side, I don't get into the drill bushing side. I get on the geometry side of the cutter. And we can put special pilots on the tools. We can put cylindrical lands on the tool so that you actually aren't making contact with the diamond and the bushing. So there's a lot of things that we can do on the cutting tool side to compensate for not being in a CNC machine. The question was, I mentioned that you can use like different kinds of tapes in the fixturing just to add a little bit of rigidity on maybe a corner that's sticking up. The question was, can you use some type of tape to get rid of the delamination of the layers? I actually have seen some, not necessarily tape, but I have seen some customers where they built into the part, if they're going to pocket through a certain section, like of a honeycomb composite material or a very unsupported part, they'll actually make a solid epoxy portion in the part. And so when they go and cut that window out of that part, it's very rigid. The issue with that's very rare. I've only seen that a couple times where the person that was cutting it was actually the person that was manufacturing the part. So they had a lot of dialogue between the two. But I've actually done it myself and seen some other customers where they'll actually freeze water and have it contained in ice as they machine it. And that'll actually help in the fixturing and holding it. So there are resins, there's waxes, there's different types of things that you can do to help with rigidity on areas you may not be able to fixture. Yeah, it depends on your customer's requirements or your requirements. I've even seen on not so much composites, but laminated shell for like mother of pearl and abalone, where they'll actually use like super glue it, and then just dump it in a tank of acetone to get rid of the super glue. But they use that as their fixturing on very delicate little parts. The question is, can we recycle the diamond? The diamond tools, the polycrystalline diamond, the solid sheet that's on there, we can relap it, reshape it, and reuse it on the tool. The diamond coating portion of it, unfortunately, there isn't recyclability of that. You can recycle the carbide, and we do, but the diamond portion is lost. Any other questions? We're at booth 3808 over in the back corner over there. So if you have any questions, feel free to come up and talk to us. Thank you very much.